All right, guys. Hi, everyone. This is the beginning of Unit 2 on basic concepts and justifications of proofs. Okay, so yesterday we did some algebra practice with systems, and our first section is going to continue talking about those systems and the invariants that we've already been working with. Okay, so if you remember, we've been working with three main invariants so far, right? So 90-degree invariants. We've had something like this with linear pairs that are equal to 180 degrees, or triangles as well. And then you have something like we were talking about segments and midpoints and how they are equal. Okay, so those three main invariants, we're going to continue working with that. Okay, so I'm going to give you one example, and this video is only with one example. So if I am going too fast, remember that you could pause it, look back at it so that you see the example, and then we'll apply it in our classroom. All right, so here's our example. If I give you two right angles, right, I'm going to say that angle XYJ is equal to 3x minus 10, and the other angle is 2y plus 5. I know that this invariant has to equal to 90 degrees, right, because of this right angle right at the corner. Same thing with our other one. So our top angle will be 2x minus 3, and our bottom one will be 5y minus 7. Okay, so we're going to do this in parts and solve the system as we go. The first thing you want to do is look at your pictures and write equations about them, right? So we already know, again, that this other angle is also 90 degrees because of that right angle marking on of the box at angle N. So we're going to go ahead and write two equations about the above information that we have in those two pictures. So the right angle on the left, I know that if I add both of those angles, the smaller angles, it has to equal to 90 degrees because it's a right angle. Same thing with the other one, right? So the one on the right, if I have 2x minus 3 plus 5y minus 7, it also has to equal to 90 degrees. Again, we just practiced solving systems, right? And you should have done this last year, where you have two or more equations with two or more variables. Okay, so that's what we're going to do. Now, before you solve the system, you need to make sure it is in standard form. Okay, so what we're going to do is we're going to rewrite these equations in that standard form. Okay, so standard form looks like this, where you have a and ax or by, so x and y on the left side of the equal sign, and your constants or your numbers by themselves on the right side of the equal sign. So we're going to turn the equations from part A into standard form, right? So we just want x and y on the left side and my numbers on the other. Okay, so we're going to go ahead and start with the first equation. So the first equation was 3x minus 10 plus 2y plus 5 equal to 90. Okay, and I'm going to look at my x's and my y's. Can I combine that with anything on the left side? No. So all we're going to do is rewrite those. Then I want to ask myself, can I combine anything else on that side? Well, yes. I can combine the negative 10 and the positive 5. That will give me a negative 5 and equal to 90. Okay, so pretend like you're solving a regular equation, except you're going to have two variables. So I'm still going to have to get rid of that 5. So remember, whatever you do to one side of the equal sign, you have to do to the other. So my final equation in standard form would be 3x plus 2y equal to 95. So this is the equation that we want to use, or one of the equations that we want to use when we are solving for the system. Okay, so we're going to do the exact same thing with our other equation. So 2x minus 3 plus 5y minus 7 equal to 90. So go ahead and pause the video for a little bit, get this equation into standard form before I move on. All right, so again, x and y, nothing combines with those, so I have 2x plus 5y. I can combine my negative 3 and my negative 7 to give me negative 10 equal to 90. add 10 to both sides, and I get 2x plus 5y is equal to 100. So now it is in standard form. Those are the two equations that I am going to use when I am solving this system, okay? Which is our next part. So we're going to use, again, those equations from part B to solve the system. So I'm going to go ahead and put them right on top of one another. So I have 3x plus 2y equal to 95, and 2x plus 5y is equal to 100. Okay, notice that I line them up so that we can use elimination. Remember that you can also use substitution. Elimination is just easier for some problems, just like substitution can be easier for other problems, okay? But there is more than one way to do it. So what I would do here is you need to remember that in order for you to be able to eliminate a variable, you need to cancel out or eliminate either the x variable or the y variable. Sometimes one variable is easier than the other one. Sometimes it's really the same thing. So it doesn't matter. You get to pick. And you also have to remember that you need opposites here. Okay, so I am going to go ahead and cancel out my x's. No particular reason. I just think they are smaller numbers. So I'm going to go ahead and multiply both of those equations to get me an equation equal to 6. Okay, so 6 is my common number between 3 and 2. So I want to make one of them a 6x, and I want to make the other one a negative 6x. And again, it doesn't matter where you put the negatives. So I'm going to multiply the top one by 2, and I'm going to multiply the bottom one by a negative 3. So if I go ahead and distribute that to all three things, all three terms, I get 6x plus 4y is equal to 190. Go ahead and do the same thing with the negative 3. Do not forget to multiply it to what it's equal to, or else you will get it wrong. You get negative 6x minus 15y is equal to negative 300. Okay, so this is the system that we will be solving. Okay, so now you're able to add and cancel out whatever you can cancel out. All right, so here, our objective was to cancel out one of the variables. We canceled out x, and now you're just adding. So 4y plus negative 15y will give you negative 11y. 190 minus 300 will give you negative 110. Then finish solving. So divide both sides by negative 11. Y is equal to 10. Okay, so now that I have my y variable, I need to use that to solve for my x, because when you're solving for a system, you're solving for both variables, not just one. Okay, so I'm going to pick one of the equations. It doesn't matter which one. I'll pick the top one. So that would be 3x plus 2y is equal to 95. And wherever I see y, I'm going to go ahead and plug in 10 since we just solved for that. So I have 3x plus 2 times 10 is equal to 95. And now you're just solving another algebra problem. Okay, so go ahead and pause the video. Finish solving for that. Subtract 20 to both sides. You get 3x is equal to 75. Then divide both sides by 3. So x is equal to 25. Okay, so now I've solved my system. But the last thing I want you to do is to find the measure of angle XYJ. So I'm going to go back to my picture here, because I need to remember what the measurement of XYJ was. Okay, so XYJ, again, the important letter here is your middle one, that is your vertex. So XYJ is this top angle of the first one, which is 3x minus 10. Okay, so I'm going to go back down to the bottom. So I know that angle XYJ was 3x minus 10. So wherever I see x, I'm going to plug in 25, which is what I just solved. So 3 times 25 minus 10 will give you 75 minus 10, which is 65 degrees as my final answer. And that's it.